Welcome again to the Sustainability Podcast. Today, I'm thrilled to have with me Steve Pullins, CTO of Alpha Structure. Steve, welcome. How are you today?
I'm doing fine. How are you doing, Jim?
Hey, that's great. It's great to see you again.
Yes.
For those that don't know Steve Pullins, can you tell us a little bit about yourself and how you came to this industry?
Sure. Well, it happened a long time ago when I was 5. I'm kidding. I've been in the energy business for well over 40 years, and I've been working on-site energy systems and microgrids for the last 18 years, and have designed more than 75 microgrids and built several and actually owned 3. And so I'm pretty all in on the idea and the concept and the advantages of on-site energy systems for commercial and industrial customers. So, and that's what we do as Alpha Structure, is, which is a joint venture between the Carlyle Group and Schneider Electric, really focused on these larger applications of these on-site energy systems. We call them microgrids for commercial industrial customers.
Okay, well, thanks for that. Before we get to the perhaps the current ecosystem, let me interject a question into my flow here. That is, for those of us who may not be terribly conversant in the technology, what is a microgrid?
Sure. So it's an on-site energy system. What I mean by that is you take a certain group of energy generating assets, like it might be a PV array, a solar PV array, or it could be a combined heat and power unit that's running on natural gas or renewable natural gas or hydrogen, that's providing not only electricity to a site, but also heat for a process application, or maybe you're putting an absorption chiller on the back end of the combined heat and power unit and creating cooling and doing space cooling with that, or doing process cooling with that. So that's what you get. And then also there's always batteries involved in that. So you've got these multiple, what we call distributed energy resources, that you put together in a smart way using microgrid controls, which are specifically designed to marry inverter-based resources and rotating equipment type resources together in a structured fashion.
Okay.
And we're really trying to create a benefit to the customer around cost, long-term cost stability, better reliability, better resilience in the face of major storms, and then of course sustainability, trying to create a more carbon-free or low carbon solution for that particular site.
Okay. So which of those technologies is most popular today, or what do you see? Because you had quite the gamut there of distributed energy resources and the software that links them.
So I think it wasn't this way 15 years ago, but everybody sees the value of solar these days. No fuel cost. It's pretty stable. Price wise, it's a long-term asset, 35, 40 years. So there's a lot of true value in the solar. So everybody's pretty much come to grips with that, both in the investment community and in the technologist community. There's long-standing value seen in the combined heat and power. So and that can be engine based or turbine based or fuel cell based, even linear engine based. That's a whole nother story. but the point is that these are all forms of what we refer to as baseload generation. In other words, it's something that can be operated 100% output for days and months, and where you don't see that with an intermittent resource like solar, right, and wind, which are renewable, but they are not a constant output. So you marry those two things together. So we're seeing one cadre of folks when we go talk to them, very familiar with the combined heat and power application. Another group very familiar with the solar. Now, when we go talk to somebody and we find somebody who's familiar with solar and CHP, that's a rare occasion. But we're trying to change that, right? We're trying to change the face of that on-site energy system, where people see that the marriage of those two things together is the value.
Oh, that's very, very insightful. So across all these technologies, what challenges do you see?
Most of the challenge that we face as a company is really education. It's about getting organizations familiar with the pieces of the energy puzzle that they haven't worked on before. So everybody's got a view on energy, but typically it's an incomplete picture. And what we try to do is we try to broaden that education at the customer level or our technology partners, so that they see that, a broader picture. So that's one of the challenges and it's not like a insurmountable challenge. It's just a challenge that takes time. So it takes time to get people educated on a full spectrum of technologies that you would apply to a microgrid or an on-site energy system. And it takes a while to do that. But people do become familiar with that over time. So that's one of the challenges. The other challenge, I would say most people would think of this as a challenge, but for us, based on why we were created as Alpha Structure, would be the financial aspects. How do you put together a capital play that doesn't challenge the customer? And we bring all the capital to the table, all right? And that's already here. It's already waiting. We just have to make sure that we're applying it to the right kind of projects. But that's not the normal thing, right? So when you go talk to a customer, often they've wanted to do something to improve many aspects of their energy service, but they haven't had the capital to do that. Now, a lot of these corporations that we're working with are larger corporations, and they have capital, but it's a matter of priority, right? So if I've got, if I've got $30 million that I'm going to do something with at a particular site, and I have the choice, okay, I'm going to put on a second shift so I can produce more, or I'm going to do R&D on a new product line so I can expand my business, or I'm going to go do a microgrid, right? So there's a direct sense of value that a customer has if it can say, okay, I'm going to add a shift, or I'm going to do R&D on a new product or grow my business that way. But energy doesn't fall under that same set of priorities, right? So it doesn't get, it always falls below the line in the annual board meeting on how I'm going to spend capital next year. It always falls below the line. But if you've got somebody else who's going to do that, and there's no capital outlay, then it's a matter of becoming comfortable with that partner who's going to provide that energy as a service. They're going to spend their capital. They're going to lay out the whole system, they're going to make it operational, and then they're going to charge us similar to an electric bill that we would get from a utility. But in this case, the electric bill is not coming from the utility, it's coming from an alpha structure. Okay.
Got it. Let me try to unpack what I thought I heard there a little bit. From an educational aspect, I think I heard that there's some education that needs to be done both on the maturity of the technology as well as the financial viability of each of these distributed resources, because there's been so much written, it's a bit divergent, some of the press releases that there's that piece. And then particularly in the environment in which we reside with rising interest rates, that's, I believe, introduces an increasing headwind against projects that have high capital upfront investment requirements, which renewables tend to have. A lot of the capital is mostly upfront, and it's not really so much periodic down down the calendar.
So it's the opportunity to change that upfront CapEx type of spend to a downstream OpEx kind of spend. So instead having that big chunk that a customer, a commercial industrial customer would have to deal with up front, take that away, and therefore take away the inflation adjusted lending costs that you would have to deal with. Okay, take that away, and then put that on somebody else's back, and then what I do is I take that from a CapEx bucket in my budget to an OpEx bucket in my budget, and then I'm getting charged an annual amount of money based on how much electricity and heat that I consume. Okay, so it changes the game and makes it more palatable to a customer.
Certainly. Could you share? Go ahead.
Yeah, and just one little clarification about the technology maturity aspect. So the technologies are mature. But people, it's a familiarity with the technologies that we often find that we need to work on with a customer. It's just they're not. I mean, there's a technology that's been around for 100 years, and people just aren't familiar with it because they never used it before. So it's not that the technology is bad or weak or immature. It's just
it's the perception.
It's the perception. Right?
Okay. Can you share some application examples of how this works in practice?
Sure. Let's talk about. I'll use a project as an example. So we're building out an energy system for JFK New Terminal 1. Okay, and New Terminal 1 at JFK Airport, New York, is replacing old Terminal 3, Terminal 2, and Terminal 1. So it's a big deal, 2.5 million square feet, $9.5 billion redevelopment effort at that airport. And we're doing the microgrid for that. So this is and why? So as you've seen, when airports go down, when the grid goes down at an airport, there's a lot of people in a vulnerable situation, and it can be hours, or it can be even longer. And that is just like the kiss of death for an airport, because you don't want to have a situation where you're canceling flights. And as we've seen in the United States, one major airport cancels a bunch of flights, and it just ripples across the rest of the country
for days.
So For days, right? It takes days to recover the schedules for that, right? Because people get diverted and yeah. So that reliability and resilience of the electricity supply to that terminal becomes really, really important. Okay, it needs to always be there. It needs to always happen, and that doesn't happen with a grid alone. So if you put on-site energy sources, okay, distributed energy resources embedded in that terminal that can supply the majority of the power at that terminal, then you are much more likely to continue operations even if there's a major storm or even if there's a loss of the grid for other reasons. So, and a major storm comes through and you say, well, that's going to cancel flights and things like that. Yeah, but I still have 40,000 people in that terminal and they need to be cared for until things pass.
That's right.
And so those aspects, and then the other thing that we see is these long-term cost increases for energy. Whether you're talking about natural gas, which is 36% more expensive today than it was in 2019, and electricity, which we've seen a lot of rate cases that are now happening and across the country. When you look at this, we're seeing annual rate changes of 3.5% to 6%. So, and over time, that really builds in a lot of additional costs. So people, all these people are looking for ways to kind of limit that upward growth of those energy costs. And then there's the whole sustainability aspect of it and reducing greenhouse gases. And in an airport, that's a big deal, right?
Yeah, it certainly is. In terms of resilience isn't talked about anywhere near as much as sustainability.
Right.
But personally, I'm interested. Can you talk about levels of redundancy in that airport or some other applications? Is it one level or are there multiple levels?
So redundancy and resilience are not the same thing.
Correct.
Okay. So redundancy by its definition is I have one thing, I need to have another thing to be redundant. Okay. And not used properly, I can have one thing, I'll do another thing, I'll do another thing, I'll do another thing, and I can end up with redundancy that just no longer makes sense. Okay, but from a resilience perspective, I look at it a little differently. So at JFK, New Terminal 1, it's a 8 megawatt average load, 13 megawatt peak. Okay, so why don't I just put a single generator there that's 13 megawatts or 8 megawatts? Okay. Well, then if I have one thing and I lose it, then I'm not redundant, or I'm not resilient.
Correct.
Okay. But if I take that 8 megawatts and I spread it across 8 things, then how likely am I to lose all 8? Not, that's like 10 to the minus 11th probability of occurrence, right? So the idea is that's what we do. So we take the load, we look at the load and we say, okay, I'm going to break that into X number of pieces. And at JFK, New Terminal 1, we've got solar arrays, we've got batteries, we've got fuel cells. Okay. And we broke it into 4 pieces. And then we have 2 fuel cells and 2 solar drops and 2 batteries at each location. So I end up with 24 pieces, okay, of generating equipment. Now I'm looking at what if I lose a piece? of equipment, then I've lost one of 24.
Right.
Okay. So that's a much more resilient methodology of how I protect against major storms or even damaging events on site where I've burned up a piece of gear or something like that. So I'm just incredibly more resilient, and I'm capable of using the flexibility in that system with 24 pieces to continue operations at a very high level, maybe not 100%, but at a very high level, and keep everybody safe and keep the planes rolling.
No, that's great, because my intuition was that perhaps there was one secondary source of power from Alpha Structure that might have supplanted the incumbent electric utility on Long Island. But that's fascinating. It's 24 and 10 to the minus 11. I'm impressed that you had that number at the top of your head.
Well, I had to argue that point with some of the authorities and stakeholders at JFK.
Oh, that's good. So the primary source of power then for this terminal will be this infrastructure?
Yes, it is the primary and largest source of power. We're still using some of the grid power, but that's if we lose the grid power, we can continue to run the terminal for days without the grid. So we're protected.
For those in the audience that are not familiar with acronyms and some buzzwords in the industry, that brings up the topic of islanding. How do you handle islanding in this scenario?
Sure. So because it's a microgrid, it can sense when we have sensors and relays that sense when the grid is challenged. So we can actually, in some cases, we can actually anticipate the loss of the grid. Okay, but even if we can't, if we lose the grid, we see the voltage and the frequency fade really quickly, talking milliseconds, and we basically open the connection with the grid. We ride through that little bump with our energy storage, which operates very fast, and we just catch everything in an island mode. So we call it a seamless transition because we're making the transition from grid connected to island mode in milliseconds, and we're doing it without a loss of any of the loads that are at that terminal or any other place where we build a microgrid.
So what do you see for the future?
That's what I see is, first of all, when we talk about microgrids, is everything going to become a microgrid? No. Okay. It just doesn't. There's a point out there where you're doing more and more microgrids, and because of market forces and that, grid prices come down, and maybe as the utilities start to incorporate microgrid concepts in their distribution systems, then reliability starts to increase. Reliability and resilience start to increase. So somewhere out there in the future, don't know which year, there comes a point where there's a happy equilibrium between centrally generated power and locally generated power, and centrally generated reliability and locally generated reliability. And all of that stuff finds its happy equilibrium out there. Maybe it's 10 years from now, maybe it's 15 years from now, but it is out there. And the microgrids are highly leverageable. So you don't need to have a 50-50 scenario. It could be 70-30, and you end up achieving better reliability and better cost controls for the customers in that future. So So that's what I see. I see an overall movement and growth of the microgrid space. I'm not the only one that sees that. And I see out there in the future a point where their market forces show a happy equilibrium between the more traditional utility supplied power and a customer side of the meter locally supplied power with a bunch of with thousands and thousands of those little pieces all over the country.
What types of projects are in the sweet spot for AlphaStructure, and when should someone pick up the phone and call you?
I would say right now we're very busy with electrification of heavy duty transportation. Okay, so there's a lot of movement around electrifying transit operations, bus operations, okay, and last mile delivery fleets and regional transport of goods, okay, things like that, where you're using heavy duty vehicles. So as we electrify transportation, you'll hear a lot of people talk about, well, the grid can't handle it, okay, and in a sense that is true. We still have room in the grid to make better use of those assets that are grid distribution and transmission and generation. We have room there, but it is a challenge. What we have seen, what we've done is we did a smart bus depot at Brookville, which is a part of Montgomery County, Maryland system. And we are using a microgrid on site to power 70 electric buses. Okay, and we're doing that without any changes or additions to the utilities grid infrastructure. Okay, so what I've just said is we completely bucked the trend, and we've enabled electrification of heavy duty transportation without affecting the grid. Okay, so this is an alternative when people think about, oh, I can't get power from the grid to do more than 5 or 6 electric buses here. What am I going to do? I'm going to have to wait 10 years for the utility to add to that infrastructure to get me the power I need. No, go ahead and do it as a microgrid, and just make your heavy duty transportation path independent of the utility. Okay, so
that's fascinating. That really is fascinating, and we probably should ask that back at the beginning where we talked about obstacles. But can you contrast for me that bus application, the microgrid entire business effort, against getting the utility to provide me whatever it is I need, which I might think is a new feeder line, a substation, and probably years or decades of approvals.
Yeah, so the business as usual approach would have been so this bus depot is about 6 megawatts, okay, and but the current capability from the local grid is 1 megawatt. So, and to achieve what the customer wanted in reliability would have required not only the single feed from the utility, but a separate feed from the utility from a separate part of their system, right? Because it doesn't make any sense to have 2 feeds from one substation coming into a site, because if I lose the substation, I lose everything anyway. So that would have required a lot of added infrastructure on the part of the utility to beef up, the existing distribution feeder and create and site and go through people's yards and things like that, a second feeder to that site. Okay. Huge amount of money to do that. Okay. Much cheaper to put resources on site. We put 2 megawatts of canopy solar PV. Okay. And we put 3 engines, 633 kW, so 1.8 megawatts. And we've got a 1.5 megawatt, 4.4 megawatt hour battery. Okay. And that plus 23 chargers, heavy duty chargers to, to actually deliver the goods. And we built that whole thing while that bus depot continued to operate.
Wow.
So it was all inbuilt, in little pieces while they continued to operate their bus fleet from there.
Fascinating.
So, yeah.
So I'm not sure you answered my most recent question, which was, what is in the sweet spot? I mean, I understand if I have a large airport terminal of 2.5 million square feet, or if need to power 70 buses. But what? How would you define the projects that are in your sweet spot?
So the way we look at it is 2 things, and we don't look at it like sector by sector, and like I said, we're very busy right now in this whole electrification of transportation, heavy duty transportation. But the real key to the customers who come to us and are interested in a different kind of solution are folks who are energy intensive and energy sensitive. So somebody who takes a 30-second grid outage and it takes them a day, all hands, to recover from that. Okay, that's energy sensitive, and losing millions of dollars. So, and then energy intensive, there's certain industries that just take a lot of energy, and along with that comes the risk of reliability and resilience, and the risk of their carbon footprint and things like that. So those folks need help, and it's all about transformation and how you look at and then deliver a different kind of energy future, not just an incremental improvement on the way we've always done it. This is transformational.
Steve, it strikes me that an airport and a public bus charging facility are both public infrastructure projects. Are you equally interested in private operators of infrastructure?
Absolutely. If I were to show you our pipeline, the majority of our projects in our pipeline that we're working on are private companies. They might be publicly traded, but they're not agencies of a government. Okay. And if you take a look at it, what we're doing at JFK is a private consortium that has the concession to redevelop the new Terminal 1. Okay, so our direct customer is not a government entity. It's this private consortium that has the rights has won the rights to do this redevelopment. But clearly the majority of people out there working on transit buses, and depots, and that are government agencies. They're county and municipal agencies. So that's clearly, in a government, local government type picture. But if I were to talk to you about the cement factories that we're working with, the tomato processing facilities, the others like that, car builders, these are all private entities.
So is there a scope of, say, energy usage that fits into the alpha structure? I mean, what's too small?
We really try to stay above 5 megawatts when we're looking at things, because we know that above 5 megawatts, we're going to be able to provide something that meets all of those 4 objectives
Okay.
for a customer, something that is stable in cost over a long period of time and actually generates savings. It may not generate savings in the first couple of years, but over time, because our costs are flat, or flatter, we're able to generate long-term cost savings.
Okay.
But somebody who's that reliability and resilience is really important, or becoming more important, and then somebody who's challenged by their sustainability needs. Yep.
What wonderful. So we've covered a lot of ground in a short amount of time. What recommendations do you have for anyone who's just entering into the thought process about microgrids and energy as a service, and more particularly?
Yeah, there are some really good resources out there to learn about it in general. I like to share with people that places like microgridknowledge.com is a good place to get a lot of across the board independent views and education about that. There's also DOE has some good materials around microgrids and how they play in the smart grid future. So those kinds of things in there, and then you can turn to turn to our website, alphastructure.com, and or Schneider Electric or Siemens or ABB, all these folks who have scale microgrid, Ameresco, all these folks who have been in the business for a decade or longer doing these microgrids. And you'll get good educational resources, or you'll get links to educational resources that way. So that's what I would do. I would bone up on microgrids, right?
That's great. Well, Steve, we're nearing the end of our time together today. Do you have any last words for our audience?
I would suggest that that a good phrase to think about is, I don't know what I don't know. Okay. And it's always good when especially if you're embarking on a very difficult problem that has a lot of pieces to it, is you need to get some advice, you need to learn, and you need to recognize that what I've done in the past may not be valid for what I need to do in the future. So you got to open up your window to be able to really start understanding what's out there and what's available to you as parts of solutions.
That's great. Well, again, our guest today has been Steve Pullins, CTO of AlphaStructure, and he's given us some tremendous information on not only microgrids, but more particularly the energy as a service offering of AlphaStructure. So, Steve, it was great seeing you again, and I'm sure we'll cross paths again in the near future. And thank you, everyone, for listening in.
Thank you.